Hi, I'm Xavier. So today I have a very interesting repair for you, and you know, the story is that a guy brought me this thing. This is a Toshiba SC-330. It's a power amplifier. I think it's 40 watts or 38 watts, and if I recall, this thing is the power amplifier for the Toshiba set. It has the all the rack-mounted, Hi-Fi equipment that Toshiba produced, and this is a very high-quality kind of product. I mean, you see those very nice view meters and those rack handles and stuff. It's very nice looking, actually, and so this thing, yes, this is actually detached, and the problem was that. He explained to me that there was a very strong crackling noise coming out of this thing only on the left channel. So I don't really know and what was the cause. So I said, well, perhaps it's a very bad contact. So try reseat, you know, the connections on the back for the speakers. So he did that, but nothing really happened. So I just say, well, just bring it to me and give it a look. So here is the actual progress. I'm actually quite far away here, but I'll try to explain you because I also had some very quick footage of the crackly noise and me opening up this thing, but I thought it was not really interesting because I thought it was just a very bad contact or whatever. But as it turns out, it's not a bad contact. It is something else, but it's very mysterious. Alright, so the problem is that what's going on with my meter on the back? Jeez, it's going up. It's going crazy. The problem also this one. Alright, that's perhaps a bad contact on the meter. Jeez. So the first thing I did, and the first thing you should do if you have a crackly noise or whatever, or if you have a known bad amplifier like that, you should just measure the output in DC and AC. Especially DC. If there is any DC on the output, so continuous current, it's something that went very bad. On this one, on the right channel, is perfectly fine. There is a offset of just below the 100 millivolts mark, and I think it was just 50 millivolts, which is just fine. But on the left channel, there was an awesome DC offset of 10 volts, plus 10 volts, yes. So I suspected, obviously the first thing you suspect when you have a DC offset like that is obviously the final stage of the amplification. So those beautiful transistors here, by the way, those are NAC, D588 and B 618, very popular in hi-fi equipment. I actually encountered those in Pioneer amplifiers and also Marantz amplifiers, so very high-end hi-fi equipment, and those are very good. The characteristics of those are very nice, but there is a problem that those are from 77, so has 41 years, and those are 41 years old, and obviously they are discontinuous nowadays, and you can't really find replacement for those, and if you actually manage to find replacements, they are very expensive. I mean, talking of 30 euros each, or a pair, for each channel. I mean, that's insane. And so the problem, I suspected first, the problem was obviously the transistor. So I measured the transistor, I completely desoldered everything. And by the way, this board here is a pain in the ass. You have to disassemble everything to take the board out. I mean, it's just, yeah, painful. But anyways, you know, as it turns out, the transistors are totally fine. So having a right channel working and the left channel not working, you can actually work without a schematic. But as it turns out, there's a complete Toshiba service manual here, very well written, only a few pages, but you know, there's a block diagram, all the operating control, the assembly instruction and everything, and obviously, oh yes, the schematic, and schematic with all the voltages written on the actual points here, and also the part location, as you can see here. So this is the actual board. You can actually see, perhaps, maybe, yes, the voltage locations here. So you just go there and probe the things, and you find out what's wrong. For example, you have this point here. This should be 0.6 volts, but instead on my board it's plus I think it was 12. There's a point here. It's supposed to be 1.05 volts, but instead is actually much higher, like 30 volts. And obviously here it's 10 volts on the output. So yeah, I mean, man, that's very, very wrong readings. You shouldn't really get those. So I suspected the first stage of the preamplification here was actually fine, but I suspected the drivers. So I measured the drivers and I just, you know, checked also those ones, and those are totally fine. I mean, the voltages are perfect, and no, the drivers are all right. So what's wrong then? I mean, I know the diodes, perhaps yes, the diodes should be completely gone, but no, the diodes are all right. So measure also the Zener Diodes here, all totally fine. Also this one, but has no sense just that this one or this one is broken, because this is a common rail here. It goes to the to the right channel as well as the left channel. So what's wrong then? So I just managed to see the bias control resistor, which is VR4. So I just checked that, but was all right. So yeah, I mean, what's going on here? Alright, so I suspected resistors, suspected diodes, you know, active components like transistors or diodes, but they are totally fine. So, man, what's going on? So I measure resistors, but they are all within spec, so nothing else. But then I realized, well, look at those capacitors. I mean, those capacitors have 41 years on their back. So I just, suspected capacitors, perhaps coupling capacitors. And as it turns out, perhaps, I still don't know what's the problem, but I'm gonna actually, troubleshoot the thing with you. So where is the 37 volts rail? Is right here. It goes there, goes through a 2.7 kilo ohm resistor, and then through a capacitor right there. So if this capacitor is bad, is electrolytic, has a kind of a small value, it's 47 microfarad, 35 volts, but from here to here it's more than 35 volts, because here you have these 37 volts, which by the way on my board it's plus 40, so it's a little bit off, but you know, it's fine. Get more gain, more amplification than that. but this one is right across a goes here and goes right through a 2.7 kilo ohm resistor, which is fine, but the capacitor is right across here. So perhaps if the capacitor was actually leaky, yeah, you actually would get a pretty decent voltage right there. So instead of 0 volts, you would actually expect finding some voltage. Alright, so it's now out of the board, and that's something quite strange here. It says supposed to be a 47 microfarad 35 volts, but this one is 47 microfarad 50 volts. So even if it actually gets more voltage than 35, will be actually alright. I don't expect this thing to be to have more than 40 volts across the leads. It should actually be alright, but if you get a closer look at this one, I mean, let me focus here a little bit. As you can see, it's cracked on the back, and also has some burnings on this lead here. And as you can see here on the board as well, there is a little bit of leakage right here, so it leaked. Look at that, there's this gunk on the back, and there is a little bit of burning right on this lead here. So I strongly suspect this thing is bad. Alright, so I replaced the capacitor. I know it's not the most elegant thing, having this huge lead here coming out, but I mean, it's just a test. So I connected the multimeter to the left channel output. 3, 2, 1. No, we see 10 volts again. So that's not the problem. Alright, so I finally managed to fix this fucker. So, after hours spent, looking for parts that might have been, blown, or I don't know, might have, received too much voltage, like 0.45, and this part here 1.05. Here I was actually getting almost 40 volts between the actual base and the emitter of this of those two transistors, and here as well. I checked everything. The transistors were all right, and I know because I repaired I had a similar situation where an amplifier was actually outputting on both channels, were actually outputting 3 or 4 volts, I don't remember, but 3 or 4 volts DC, which is bad. I mean, it's not supposed to be like that. So yes, the fuse were blowing, and I repaired it because the problem obviously was that the actual final transistor, the final stage of the amplification, were actually shorted. So all the voltage they receive, and almost all hi-fi amplifier with this kind of situation here have this kind of arrangement of the transistors. You have a NPN and PNP transistors in the push-pull configurations here. It's actually balanced on the middle, and you can actually see it here. They receive 37 to the collector, this NPN transistor, and on this one, which is a PNP transistor, it receives -37, and this is a class A/B kind of procedure of amplifying the signal. It's a very nice actual way of amplifying signal, and it doesn't really get too much distortion. It's not really efficient, but anyways, on those kind of hi-fi equipment, you are not looking for efficiency, you are gonna look for sound quality, and this one is a very nice way of amplifying the signal. And yes, but by the way, that time those transistors were shorted. So what happens? Well, it's easy. Now, it's 37 volts. It goes straight across the line, and boom, you get a much higher voltage right on the middle. I was actually getting like 3 or 4 volts because it was not a complete short, was actually become a resistor. But anyways, this time here I was actually getting 10 volts on the output, which is a very high voltage. It shouldn't be like that. And it's a very dangerous situation because if you just plug a speaker, as I said, it will actually blow the fuse. And if you hardwire the fuse, it will blow the speaker because you have a DC component on the output. You should never have a DC component on the output. It should be very low on DC. Like, you know, 50 millivolts maximum, or, you know, even 100 on higher, you know, wattage, higher power amplifiers. But those were the first thing I actually checked. I also desoldered everything here, the actual heatsink. I had to take that off and desolder every single transistor and test it. But they were perfectly right. And I also, so I said, well, if it's not there, the problem is on the pre-amplification section. So those are the drivers for the final stage, and those are those transistors right there. You probably can't see it, but anyways, you know, I checked those, but they were fine. And I also, since I don't really have the replacement for them ready here in the lab, so I just, if you have, the great thing about this repair is that you have another channel to, as a reference, you know, to compare. So I just took those and, you know, I swapped them, basically. So, and now they are still swapped, I think, yes. So I swapped them and perfectly fine. So the left channel with the right channel with the left transistors that was supposed to be bad was actually working perfectly fine. So transistors were not a problem. So where is the problem? Capacitors, maybe a leaky capacitor, as you have seen. I also replaced the capacitor that was right here. I was actually suspecting that because, you know, it's right across here and it receives a high voltage from here. And if this becomes conductive, you will see a high voltage right there. But this is not conductive. It's not leaking too much, at least. Anyways, capacitors are not a problem in this case. Resistors, perhaps. So I checked the resistors. The resistors were, you know, visually, the resistors usually have visual indication when they're, you know, gone, where they're bad. And no, every resistor was fine. You know, I checked everyone. There are very few resistors, I mean, for each channel. So it's not a you know, a 10 minutes job. You just check every resistor in circuit. Doesn't really matter. But anyways, the resistors were fine. So diodes, I suspected those diodes here, but no, they were fine as well. A very interesting thing is that, you know, see this resistor right here, this one? I don't know if you can see it, but, man, this one here, this is new. I actually replaced that because, you can actually see here, R47. Alright, supposed to be a 15K resistor, 2 watts. But on here, on the board, was actually mounted a 1.5 kilo ohm resistor, not a 15 kilo ohm. So 1.5 and 15, it's a very high difference in impedance. It seemed original. I mean, I still have the resistor. Let me actually find it. There it is. And you can actually see this in the older video. You can actually see it. It's a 1.5. Look at that. It's a 1.5 kilo ohm. But on the schematic, R47 supposed to be 15. So yes, so now it actually works. Works again. I still have to check every single you know, test point on here, and you know, the thing is that now I don't really want. No, it's just a matter of you know, fixing, you know, small stuff. The hard thing, you know, of fixing the amplifier section is actually done. I wanna actually replace those lamps with LEDs. This is those are supposed to be 14 volts lamps. So yeah, I don't know why they're driving them with 6 volts. I mean, yeah, it's half. Yeah, but anyways, in fact, the light on the view meters, on the power meters, were actually very dim. I wanna actually have a very bright light illuminating those needles, because I love the needle meters on this unit, and you know, I just want to actually make it look better. So I just gonna do that, and I also repainted the lid and the bottom because it was completely rusted. So what I did is I, you know, sanded the panels and repainted everything. Just, you know, very quick job, but it's gonna actually look much better and will last longer. So I completely cleaned the thing, and I also, as you can see, I cut the wire because there was this huge mess of tape, and you know that I just hate electrical tape. Please don't use electrical tape on wires like that. I mean, not as a permanent solution. You know, the wire was sliced, but not even isolated. They were just there dangling right. My God, that was one of the most dangerous things you can possibly do. Also, I replaced the 2 capacitors that were between the main switch. So I'm gonna replace it with those new ones. They are rated X2, so that's perfectly nice. Alright, so now that it's actually back working again, I just want to do the only adjustment you can actually do on this thing, which is the idle current adjustment, and it actually is written very nicely on here. And as you can see, you have to measure the voltage between those 2 resistors. On the schematic, it's much better. You have to measure between those 2 points right here, and between those 2 points on those 2 resistors, which are 4 because, you know, you have 2 channels. And the reading is 2.4 millivolts immediately after power switch on, idle current 5 milliamps. So I'm gonna switch it on. So let's come back. Okay. So clockwise is the way. So it's 19 millivolts. Let's go and make it like that. It's minus 40. Let's see now. Now it's 0. So just a tiny bit. Yeah, it's reasonable. Let's switch the other side. Let's discharge the capacitor first. Should be lower. Okay, so that's the way to go. Let's go a little bit more. It's very touchy, actually. Okay. That's very close. We are in the ballpark. I mean, it's very touchy, so 2.4 millivolts, you're not gonna achieve that. Alright, so now we're gonna check some other voltages on various points of the board, so we can actually make sure that this thing actually works. Okay, so the first test point gonna measure is the middle point right here, 0.6 volts right there. So I don't know if you can see it, but we have a 0.618, which is good. We should have a minus 1.1 volts on TR6. It's yeah, a little bit on the low, on the high side. But anyways, and the other channel should be the same. There we go. That's actually very close. Then we should have a 0.45 volts right there. So we should have a 0.45 and we see 0.48. Okay, so on the other channel is 0.49, which is good. Okay, so we have measured everything and everything is as it's supposed to be. And remember, when you're working with those things, the capacitor will remain charged for a long time. As you can see, there's still minus 25 and plus 10 volts. Alright, so the Toshiba power amplifier SC-330 quite a mysterious kind of repair this time. I mean, I still don't know really what went wrong. My suspicion is that you know, cleaning and resoldering multiple times, you know, transistors and stuff. I just fixed it because it was just a bad connection or a solder joint or whatever. The capacitor, the whole capacitor replacement is arriving, and I won't really bother you with the capacitor replacement. It's just a matter of you know, desoldering all the capacitors and replace them with the new ones. We'll actually make a video for the preamplifier that comes with it, and which is the model SY-330, always from Toshiba, and I'm gonna change all the capacitor also on that one, and we're gonna reassemble everything, and we're gonna see them in action. So that's it for today. I think it was actually quite interesting troubleshooting this old Toshiba power amplifier. And I'm always fascinated about old equipment like this, which is very well constructed. Actually, it's a very nice amplifier, and I think it will actually sound very good for a long time. And you know, that's basically it. So thank you for watching, and as always, I'll see you next time. Bye.